Right now, as you sit there watching this, the universe is putting on a show, a spectacle so strange, so utterly baffling, that even the brightest minds on Earth are left scratching their heads. Imagine this: out in the endless black, stars are vanishing without a trace. Planets are screaming through space at speeds that defy physics. Entire galaxies are behaving like they're alive, twisting and dancing in ways that shouldn't be possible. And that's just the beginning. The cosmos is full of secrets, and today we're pulling back the curtain on 25 of the most mind-bending, spine-tingling phenomena happening right this second. These aren't just curiosities, they're cosmic enigmas that challenge everything we think we know about reality itself. Picture this: a star so dark it absorbs light instead of emitting it. A black hole spinning so fast it warps time around it like taffy. Or a nebula shaped like a human hand, stretching its ghostly fingers across light years of emptiness. These aren't scenes from a sci-fi movie. They're real, they're out there, and they're happening as we speak. The universe doesn't play by the rules we've written for it. It's a place of infinite wonder and unimaginable strangeness, where the laws of physics seem to bend and break on a whim. And the craziest part, we've only just begun to scratch the surface of what's really going on out there. So buckle up, because we're about to take a journey through the most bizarre, the most inexplicable, and the most downright eerie events unfolding in the cosmos right now. From celestial oddities that seem almost too perfect to be random, to cosmic puzzles that have scientists debating in hushed tones, this is a tour of the universe's greatest mysteries. By the time we're done, you'll see the night sky in a whole new light, not just as a collection of distant points, but as a living, breathing, and utterly unpredictable frontier. Ready to have your mind blown? Let's dive in. Deep in the cosmos, a signal pulses with clockwork precision. A burst of radio waves so powerful it crosses billions of light years just to reach us, repeating every 16 days like a cosmic heartbeat. Scientists first detected this fast radio burst, known as FRB 180916, in 2018, but its eerie regularity turned a mystery into a full-blown enigma. Most fast radio bursts are one-off events, blips of energy that vanish as quickly as they appear, but this one, it follows a pattern so exact you could set your watch by it. Where could such a signal come from? The leading theory points to a highly magnetized neutron star, spinning like a lighthouse beam and sweeping its energy across our line of sight. But there's a twist. The signal's precision is unlike anything we've seen from known cosmic objects. Some have even dared to whisper the possibility of artificial origins. Could this be a beacon from an advanced civilization? While that idea remains far-fetched, the truth is, we simply don't have an answer yet. What we do know is that this repeating signal defies our current understanding of how the universe communicates. Think about it: something out there in a galaxy 500 million light-years away is sending out bursts of energy with mathematical regularity. It's as if the cosmos is tapping out a code, one we're only beginning to decipher. And every time we think we're close to solving the puzzle, the universe throws us another curveball. Whether it's the furious spin of a dying star or something even stranger, this 16-day cycle is a reminder that space still holds secrets we've only begun to uncover. 800 million light-years away, something impossible is happening. A supermassive black hole is belching, not just once, but in a rhythm so precise it could set the universe's metronome. At the heart of a distant galaxy, this cosmic behemoth devours surrounding gas and dust, but it doesn't do so quietly. Every 8.5 days, it emits a violent X-ray flare, a burp of energy so powerful it outshines entire stars. Scientists first noticed this bizarre cycle in 2018, and ever since, they've been scrambling to explain why a black hole would snack on such a strict schedule. Black holes aren't supposed to be predictable. They're cosmic vacuum cleaners, sucking in everything that strays too close with a hunger that warps space itself. But this one, it's like a gluttonous diner pausing between bites. The leading theory suggests an unseen companion, perhaps a second, smaller black hole, swings past it in an elliptical orbit every 8.5 days. As it approaches, its gravity tugs at the disk of superheated material spiraling into the larger black hole, stirring up a storm of energy. Like a spoon scraping a pot, this interaction could trigger those periodic X-ray flares. But here's where it gets weirder. Most black holes emit bursts of energy when they stop feeding, like a final cough after a meal. This one flares up while eating, as if it's choking on its own cosmic snack. Some researchers suspect magnetic fields around the black hole might be twisting into knots, snapping like rubber bands and releasing those explosive bursts. Others wonder if we're witnessing a never-before-seen phase of black hole behavior, a middle ground between feast and famine. The strangest part, this isn't just a curiosity. It's a clue. If black holes can operate on clocks, it changes how we understand their role in shaping galaxies. These aren't just silent destroyers, they're dynamic engines pulsing with energy that might dictate how galaxies grow, how stars form, even how the universe itself evolves. And right now, one of them is hiccuping its secrets across the cosmos, 8.5 days at a time. In the vast emptiness between stars, a world drifts alone, no sun to warm it, no orbit to anchor it, just endless night. This rogue planet, known as CFB DSR 214900403, wanders the cosmos like a ghost, glowing faintly with the fading warmth of its birth. Most planets are bound to stars, held in place by gravity's embrace, but this one, it's a cosmic vagabond, untethered and untamed. Discovered in 2012, this free-floating world challenges everything we thought we knew about how planets form. It shouldn't even be visible to us without a star's light to illuminate it. Rogue planets are usually invisible, lost in the dark. But CFB DSR 214900403 still radiates a dull red heat, the leftover energy from its violent formation. Scientists estimate it's only around 130 million years old, a toddler in cosmic terms. And its temperature hovers near 400 degrees Celsius, making it just warm enough to detect. How does a planet end up alone in the void? The leading theory suggests it was violently ejected from its home system, flung into the abyss by a gravitational tug of war between larger planets. Imagine a game of cosmic pinball where a young world gets too close to a gas giant and is slingshotted into the darkness forever. But there's another, even stranger possibility. Some rogue planets might form on their own, collapsing directly from clouds of gas and dust like failed stars. If that's true, the line between planet and star is blurrier than we ever imagined. What makes this lonely wanderer so fascinating isn't just its existence, it's what it tells us about the universe's hidden population. Rogue planets might outnumber stars in our galaxy by the trillions, drifting unseen through the interstellar night. Some could even harbor life, warmed not by sunlight but by geothermal heat or thick atmospheres trapping internal energy. Picture an ocean world floating in perpetual darkness, its depths heated by volcanic vents, a shadowy echo of Earth's own origins. CFB DSR 214900403 is more than a curiosity. It's a clue, a piece of the puzzle in understanding how planets, and maybe even life, might exist in the most unexpected places. The universe, it seems, has a way of creating worlds where we least expect them. And as we peer deeper into the dark, who knows what other lonely travelers we might find? In the cosmic dance of destruction and beauty, two galaxies twirl around each other like partners in a gravitational tango, their shapes twisting, stretching, tearing apart in slow motion. Known as the antennae galaxies, this pair has been locked in a celestial embrace for hundreds of millions of years, their spiral arms pulled into long, luminous streamers that resemble insect antennae. Every swing, every close pass sends shockwaves through their structures, triggering bursts of star formation so intense they glow like fireworks. But this dance isn't graceful, it's chaotic, violent, and utterly mesmerizing. Collisions like this should be rare. Space is vast, and galaxies are islands adrift in an ocean of nothingness. Yet here, gravity has orchestrated a collision course that warps time itself. Stars aren't actually crashing into each other, they're so far apart that even in this cosmic pileup, they slip past like ghosts, but the gas and dust between them. That's another story. Compressed by the galaxy's gravitational pull, these clouds collapse into nurseries for new stars, blazing to life in pockets of brilliant blue. The antennae galaxies are a glimpse into our own future because in 4 billion years, the Milky Way and Andromeda will begin their own disastrous, dazzling waltz. Now let's leap from chaos to emptiness. In the constellation Boötes, there's a hole in the universe, a void so vast and desolate it defies logic. Stretching 330 million light-years across, the Boötes Void isn't just a quiet corner of space. It's a near-perfect sphere of nothingness containing only a handful of galaxies where there should be thousands. If you were to stand at its center, the night sky would appear almost black, with just a few pinpricks of light breaking the darkness. How does a void this enormous even exist? One theory suggests smaller voids merged over billions of years, like soap bubbles combining into one colossal emptiness. Others speculate something more unsettling, that the void is evidence of an ancient collision with a parallel universe, a scar left behind by a reality we can't see. Whatever the cause, the Boötes Void is a stark reminder that the universe isn't just unpredictable, it's full of gaps we can't yet explain. Put these two phenomena side by side, and you get the universe's ultimate contrast. On one hand, galaxies so close they're tearing each other apart. On the other, a void so empty it feels like a cosmic oversight. Together, they show us the extremes of existence, how space can be both crowded and desolate, violent and eerily still. And somewhere between those extremes, we're left wondering, is the universe playing by rules we just haven't discovered yet? In the constellation Centaurus, a star flickers with a secret, one that shouldn't be possible. Przybylski's star, a seemingly ordinary speck in the night sky, is anything but. Its light carries the fingerprints of elements so rare, so unstable, that their very presence defies the laws of physics. We're talking about substances like promethium, an element with a half-life of just 17 years. That's the cosmic equivalent of finding a perfectly preserved ice cream cone in a desert. It should have melted away eons ago. Yet here it is, glowing defiantly in the heart of a star that's billions of years old. How does a star become a cosmic junkyard for elements that shouldn't exist? Normally, stars fuse lighter elements into heavier ones, creating the building blocks of the universe. But Przybylski's star is like a mad chemist's lab, packed with radioactive oddities that decay faster than a star can produce them. Some scientists have proposed wild theories to explain this, like neutron stars nearby bombarding it with exotic material, or even the unthinkable, that we're looking at the remnants of an advanced civilization's nuclear waste. That's right, alien garbage. The idea is that a highly technological species might have dumped spent fuel into their local star, leaving behind a radioactive signature we're now detecting across interstellar space. But let's not jump to conclusions. There's another, even more mind-bending possibility. We might be witnessing an entirely new kind of stellar behavior. Some researchers suggest the star could be tapping into unknown quantum processes or exotic states of matter, creating these elements in ways we've never imagined. It's as if the universe handed us a cosmic Rosetta Stone, and we're still learning how to read it. What makes Przybylski's star so thrilling isn't just the mystery, it's the implications. If stars can naturally produce these elements, our understanding of nucleosynthesis, the way stars create matter, is woefully incomplete, and if it is evidence of alien activity, Well, that changes everything. Either way, this strange stellar oddity is forcing us to rewrite the rules, proving once again that the universe is far weirder and far more wonderful than we ever dreamed. So while we stare at this tiny pinprick of light, remember, it's not just a star. It's a question mark written in the fabric of space itself, daring us to unravel its secrets. And whether the answer lies in undiscovered physics or something even more extraordinary, one thing's for certain: the cosmos still has plenty of surprises up its sleeve. Millions of galaxies are on the move, but not in the way they should be. Across the cosmos, entire clusters of galaxies are drifting in the same direction, as if pulled by an invisible hand. This bizarre phenomenon, dubbed the dark flow, defies everything we know about how the universe expands. According to our best models, the motion of galaxies should be random, scattering outward evenly from the Big Bang like seeds from an exploding fruit. Yet when scientists mapped the velocities of over 1,000 galaxy clusters, they found something unsettling: a coordinated rush toward a single point in space, one that lies beyond the edge of the observable universe. What could possibly exert such a titanic gravitational pull on so many galaxies? The leading theory is as mind-bending as the mystery itself. Our universe might be brushing up against another. Imagine two soap bubbles floating in a void, barely touching. The gravity of a neighboring universe with its own stars, galaxies, and physical laws could be tugging at ours, creating this cosmic river of motion. It's a tantalizing hint that we're part of something far larger, a multiverse where countless realities jostle unseen. But not everyone's convinced. Skeptics argue the dark flow might expose flaws in our understanding of gravity or the aftereffects of the Big Bang. Perhaps space-time itself is warped on scales we can't yet measure, or leftover ripples from the universe's birth are still nudging galaxies askew. Then there's the detective work. To spot this motion, scientists had to subtract the expected expansion of the universe from each galaxy's movement, like isolating a whisper in a hurricane. Some say the signal might just be noise, a cosmic mirage created by incomplete data. Yet the evidence keeps growing. New observations suggest the dark flow extends even farther than we thought, billions of light-years across, with galaxies racing toward the unknown at speeds exceeding 2 million miles per hour. If this is real, it rewrites the rules. The universe isn't just expanding, it's being steered. And whatever's doing the steering lies in the darkness beyond our vision, a shadowy presence we can only detect by the trails it leaves in the stars. Whether it's a distant universe next door or a gap in our cosmic equations, the dark flow forces us to confront a humbling truth. We're still novices in a universe that plays by rules we've only begun to glimpse. And as those distant galaxies surge toward the unknown, they carry with them a silent challenge: to look beyond the edges of our maps and ask what else might be out there pulling the strings. Right now, an invisible storm is raging through our galaxy, a hurricane of dark matter moving at 500 kilometers per second, and it's passing straight through Earth as if we weren't even here. This isn't science fiction. It's a real phenomenon scientists call the S1 stream, a river of particles left behind when a dwarf galaxy was torn apart by the Milky Way's gravity billions of years ago. Today, its remnants streak through space like cosmic shrapnel, and they're forcing us to confront one of the biggest mysteries in physics: what is dark matter? The S1 stream isn't like anything else in our galaxy. We can't see it directly, but its presence is betrayed by the subtle wobbles of stars caught in its wake. Imagine tossing a handful of pebbles into a pond. The ripples they create reveal the splash, even if you didn't see it happen. That's how astronomers detected this dark matter hurricane, by tracking the strange, synchronized motions of stars that shouldn't be moving in unison. The sheer speed and density of this stream suggest it's packed with something far stranger than ordinary matter particles that don't interact with light, with us, or with anything except gravity itself. This is where the standard model of physics starts to crack. Our current understanding of the universe can't explain dark matter. It's like having a map that accounts for every city, every road, but leaves out the actual land. 95% of the universe is missing from the equation. The S1 stream is a golden opportunity to finally detect these elusive particles. Experiments like Xenon and LUX, buried deep underground to shield them from cosmic noise, are on the hunt for the faintest whispers of dark matter collisions. But so far, nothing. The particles either don't behave as predicted or there's something even weirder than we imagined. Some theorists have started to question everything. Could dark matter be made of primordial black holes forged in the chaos of the Big Bang? Or perhaps it's a shadow universe of particles that barely interact with ours, coexisting like ghosts in the same room. The S1 stream amplifies these questions because if dark matter is truly invisible in every way except gravity, it means we're surrounded by an entire hidden architecture shaping the cosmos, and we're only now learning to sense its currents. Here's the kicker: this hurricane isn't just passing through, it's part of us. The atoms in your body, the chair you're sitting on, they're all porous to dark matter. Billions of these particles could be flowing through you right now, leaving no trace. It's a humbling thought. The universe is far more crowded than it appears, and we're just beginning to glimpse the invisible forces that move it. The S1 stream isn't just a scientific curiosity, it's a cosmic wake-up call, reminding us how much we still have to learn about the dark heart of reality. In the constellation Serpens, a dead star hosts one of the most extravagant cosmic relics ever discovered, a planet that shouldn't exist. PSR J17191438b isn't just another world. It's a diamond the size of a planet, forged in the apocalyptic death throes of its parent star. This bizarre orb, roughly 5 times Earth's mass, is likely composed of crystallized carbon, compressed so tightly its atomic structure resembles a cosmic gemstone. Imagine holding a diamond so vast it could fill a solar system's worth of jewelry stores, and then realizing it's floating in space, untouched and unseen for millennia. This planetary jewel didn't start as a luxury. Its story begins with a pulsar, the spinning corpse of a massive star that went supernova. The explosion was so violent it stripped away the outer layers of a nearby gas giant, leaving only its dense core, a core rich in carbon, crushed under pressures 1,000,000 times greater than Earth's atmosphere. Over billions of years, that carbon crystallized into something extraordinary, a diamond world, cold and dark, orbiting its dead star every 2 hours in a gravitational waltz. Yet for all its glamour, this planet is a cosmic orphan. Its parent star's death ensured it would never host life, never bask in warmth, never even reflect like the way Earth does. It's a monument to excess in a universe that rarely wastes anything, a glittering paradox of scarcity and abundance all in one. Now shift gears to a world on the opposite end of the survival spectrum. HD 70642b isn't made of diamonds, it is one, not in composition but in rarity. This gas giant was violently evicted from its home system, catapulted into interstellar space at a staggering 1.2 million miles per hour. Most planets cling to their stars for dear life, but this one, it's a runaway, a cosmic fugitive with no destination and no way home. The forces behind its exile are brutal. Astronomers suspect a close encounter with another massive planet or passing star sent it careening into the void, a gravitational slingshot with no return ticket. Now it drifts through the galaxy's icy darkness, untethered and alone. Unlike the diamond planet, which orbits in predictable precision, HD 70642b is a wanderer with no path, no rhythm, just the endless pull of gravity's whim. What makes these two worlds so fascinating isn't just their extremes, but what they reveal about planetary fate. One is a relic of destruction, refined into something precious. The other is a testament to chaos, flung into the abyss by forces beyond its control. Together, they're reminders that the universe doesn't just create worlds, it sculpts them, tests them, and sometimes discards them. Whether polished into perfection or cast into the dark, every planet has a story, and these too, theirs are written in stardust and solitude. Somewhere in the depths of space, an invisible force is dragging our entire galaxy toward it along with hundreds of thousands of others. This cosmic puppet master, known as the Great Attractor, exerts a gravitational pull so immense it bends the motion of galaxies across a swath of the universe stretching over 250 million light-years. But here's the catch, we can't actually see it. The Great Attractor lies hidden behind the Milky Way's own galactic plane, obscured by thick clouds of dust and stars in what astronomers call the zone of avoidance, a blind spot where our view of the deeper universe vanishes behind a curtain of cosmic clutter. For decades, this region frustrated scientists. Imagine trying to map a city while standing in the middle of a dense fog. You know something's out there, but the details are just beyond reach. That's the challenge with the Great Attractor. X-ray and infrared telescopes have pierced some of the obscuration, revealing a colossal concentration of mass roughly 600 quadrillion times heavier than our Sun. But the closer we look, the more perplexing it becomes. At the heart of this gravitational anomaly lies the Norma Cluster, a gathering of galaxies so massive it should account for the pull, yet even combined, their mass falls far short of explaining the Great Attractor's influence. So what's really lurking behind the cosmic veil? One radical theory suggests an unfathomably huge concentration of dark matter, an invisible scaffold weaving through space, bending galaxies toward it like marbles rolling into a hidden valley. Others speculate we're seeing the fingerprints of something even larger, the Laniakea supercluster, a vast web of galaxies spanning 500 million light-years, with the Great Attractor as its gravitational center of mass. Picture a whirlpool in an ocean with galaxies flowing toward its core in great, slow-moving rivers. That's Laniakea, and we're caught in its current. But the plot thickens. Recent observations hint the Great Attractor might not be the end of the story. There's evidence of something beyond it, an even greater pull dubbed the Shapley Attractor, tugging our galaxy and its neighbors toward a point nearly 700 million light-years away. This raises a spine-tingling possibility. What if these attractors are just waypoints in a far grander cosmic flow, a cascade of gravity we're only beginning to trace? The irony is delicious. For all our telescopes and technology, one of the most powerful forces shaping our galactic neighborhood remains largely hidden, teasing us from behind a wall of stardust. Whether it's a singular behemoth or part of a hierarchy of unseen structures, the Great Attractor reminds us that the universe loves a good mystery, and that sometimes the most important answers lie just out of sight, waiting for us to peel back the veil. In the Kinman dwarf galaxy, 75 million light-years away, a star simply disappeared. Not dimmed, not faded, vanished entirely, as if someone flipped a cosmic light switch. In 2009, astronomers observed a luminous blue variable star, a monstrous giant 2.5 million times brighter than our Sun, burning ferociously at the galaxy's heart. But by 2019, when scientists turned their telescopes back to study it, the star was gone. No explosion, no debris, no farewell fireworks, just an empty patch of space where a celestial titan once roared. This wasn't just any star. Luminous blue variables are cosmic divas, prone to violent outbursts and dramatic transformations. They're the type of stars that should go out with a bang, a supernova so brilliant it outshines entire galaxies for weeks. Yet when this one vanished, it left no trace. The leading theory, it might have quietly imploded into a black hole without the usual fanfare. Normally, when massive stars die, their cores collapse, triggering shockwaves that rip apart the outer layers in a supernova explosion. But in rare cases, if the conditions are just right or just wrong, the star might skip the fireworks entirely, collapsing directly into a black hole as if swallowed by its own shadow. Then there's the stranger possibility. What if the star didn't collapse at all? Some researchers speculate it might have dimmed suddenly, shrouded itself in thick dust, or even been obscured by an unnatural structure, though that last idea veers into science fiction. Others wonder if we witnessed a cosmic magic trick, a star that survived its own death throws by ejecting massive amounts of material, transforming into something entirely new before our eyes. The implications are staggering. If stars can vanish without a trace, it means our cosmic senses might be missing entire chapters of stellar life cycles. We've long assumed we understand how stars live and die, but this enigma forces us to reconsider. Could there be other stars that slipped away unnoticed, their deaths silent and undetected? Or was this a fluke, a once-in-a-universe event we just happened to catch? For now, the Kinman Dwarf's missing star remains a ghost story written in starlight, a reminder that even the brightest giants in the cosmos can vanish without warning. And as we search for answers, one unsettling question lingers. If a star this massive can disappear so quietly, what else might be hiding in the darkness? Among the hundreds of thousands of stars monitored by the Kepler Space Telescope, one stood out not for its brilliance but for its bizarre behavior. KIC 8462852, better known as Tabby's star, dims in ways no ordinary star should. Its light doesn't just dip smoothly like a planet passing in front. It flickers unpredictably, sometimes dropping by a staggering 22% before bouncing back. That's like watching a 100-watt bulb suddenly dim to 78 watts for no apparent reason, and then brighten again as if nothing happened. When the star's odd flickering was first spotted in 2015, astronomers scrambled for explanations. The leading theory pointed to a colossal swarm of comets, thousands of them orbiting the star in tight formation, periodically blocking its light. But there's a problem. Even an army of comets shouldn't cause such extreme, irregular dips. The dimming patterns don't match any known natural phenomenon, leaving scientists with a cosmic riddle that's only grown stranger with time. This is where things get wild. One audacious hypothesis suggested we might be looking at evidence of an alien megastructure, a Dyson sphere, or at least parts of one. The idea is that an advanced civilization could be harnessing the star's energy by building vast orbiting solar collectors, blocking its light in erratic ways as construction progresses. It's a tantalizing thought, but before we jump to extraterrestrial conclusions, let's be clear. Extraordinary claims require extraordinary evidence, and so far the evidence is anything but clear. Recent observations have only deepened the mystery. In 2017, Tabby's star dimmed again, this time in a way that ruled out solid megastructures. Instead of blocking all wavelengths of light evenly as an opaque object would, the dimming affected blue light more than red. That points to something diffuse, like dust scattering the star's light unevenly. Yet even this explanation feels incomplete. The dust would have to be orbiting in a bizarre, asymmetrical cloud, unlike anything we've seen in young stellar systems. Now here's where it gets even weirder. Long-term studies show Tabby's star isn't just dimming erratically, it's been slowly fading overall for over a century. Old photographic plates reveal the star has lost nearly 20% of its brightness since the 1800s. No known stellar process accounts for this gradual, century-long dimming combined with those sudden, dramatic dips. Could it be some undiscovered stellar phenomenon, a massive ringed planet with chaotic debris, or are we glimpsing something truly unprecedented, a star unlike any other in our catalogues? The truth is, after years of scrutiny, Tabby's star refuses to fit neatly into any box. It's a reminder that the universe always has another surprise waiting, another curveball to throw just when we think we're closing in on an answer. Whether it's a natural oddity or something beyond our current understanding, this star challenges us to keep looking, keep questioning, and stay open to possibilities we haven't even imagined yet. Because sometimes the most fascinating discoveries aren't the ones we can explain, but the ones that stubbornly, brilliantly defy explanation. Deep in the cosmic void, a galaxy stares back at us empty. Not of stars, not of light, but of the very thing that should bind it together, dark matter. NGC 1052DF2 isn't just unusual, it's a cosmic heretic, a sprawling collection of stars drifting through space with almost none of the invisible glue that holds other galaxies together. Discovered in 2018, it's the astronomical equivalent of finding a skyscraper floating in midair with no foundation, and its existence is forcing scientists to tear up the rulebook on how galaxies are born. Dark matter isn't just a minor ingredient in the universe, it's the scaffolding. Every galaxy we've ever studied swims in a vast halo of it, an unseen gravitational net that keeps stars from flying apart. Without dark matter, the math simply doesn't add up. Stars orbit so fast that centrifugal force should fling them into the void, yet something unseen holds them in place. That something we assumed was always dark matter, until NGC 1052DF2 came along. This ghostly galaxy, 70 million light-years away, moves like a ship without an anchor. Its stars creep along at a leisurely pace, their motion so sluggish that the galaxy's visible matter alone can account for its gravity. No dark matter needed. At first, researchers thought they'd made a mistake. Perhaps the galaxy was closer than estimated, throwing off calculations, but follow-up observations only deepened the mystery. Not only does NGC 1052DF2 lack dark matter, it's also missing other galactic staples like a central bulge or spiral arms. It's a cosmic minimalist, just stars scattered like glitter in a dark room. How does a galaxy like this even form? One theory suggests it's a failed galaxy, born from gas so calm it never sparked the density fluctuations needed to attract dark matter. Another proposes it was once part of a larger galaxy, violently stripped of its dark matter in a collision, like a fruit peeled of its skin, leaving only the pulp behind. But here's the twist. If that were true, we'd expect to see tidal tails or other signs of disruption. NGC 1052DF2 shows none. It's pristine, untouched, as if it formed this way from the beginning. The implications are staggering. If galaxies can exist without dark matter, it means our models of cosmic evolution are missing a crucial chapter. Maybe dark matter isn't the universal architect we thought it was. Maybe it's just one tool in the universe's toolbox with other, stranger mechanisms at work. Or perhaps NGC 1052DF2 is a cosmic fluke, a statistical anomaly in a dark matter-dominated cosmos. But then, in 2019, astronomers found another one, NGC 1052DF4, a second dark matter-free galaxy in the same neighborhood. Two outliers might be coincidence, but it hints at something deeper, a hidden pathway of galaxy formation we've yet to understand. These enigmatic objects are more than curiosities, they're keys to unlocking the diversity of cosmic structure. For now, NGC 1052DF2 stands as a quiet rebel, challenging our assumptions with every silent orbit. It's a reminder that the universe rarely follows the rules we write for it, and that sometimes the most profound discoveries come from the absence of something rather than its presence. Half a universe away, a cosmic mirage twists the laws of physics into a pretzel. Quasar SBS 0915 plus 521 isn't just a brilliant beacon at the heart of a distant galaxy, it's a time machine, showing us multiple versions of itself simultaneously. Thanks to the immense gravity of a foreground galaxy cluster, its light doesn't take one straight path to Earth but gets bent around the massive object like water flowing around a rock. Some photons take the scenic route, arriving years after their siblings. Others squeeze through warped space-time at different angles, creating four distinct images of the same quasar arranged in a cross-like pattern, a phenomenon called an Einstein cross. Here's what makes this celestial magic trick so extraordinary. We're not just seeing multiple copies, we're seeing the same quasar at different points in its history. The light forming each image traveled a unique path, meaning some images show the quasar as it appeared 1200 years earlier than others. It's like having 4 television screens tuned to the same channel, each showing the program at different delays, allowing astronomers to literally watch the quasar's violent outbursts unfold in staggered time. These delayed broadcasts reveal details about the quasar's structure that would otherwise be impossible to study, like catching echoes of its ancient eruptions rippling through space. Now shift your gaze to an even more perfect illusion, the Canaria's Einstein ring, a near-flawless circle of light hanging in space like a cosmic halo. When 2 galaxies align with Earth with perfect precision, the foreground galaxy's gravity bends the distant galaxy's light into this stunning optical phenomenon. The ring isn't just beautiful, it's a precision tool. The degree of distortion reveals the mass of the foreground galaxy's dark matter halo with unmatched accuracy. Some rings even show multiple images of supernova within the background galaxy, repeating like cosmic déjà vu around the luminous band. What ties these 2 phenomena together isn't just their visual spectacle, it's how they turn the universe itself into a giant lens. Without gravitational lensing, many of these distant objects would be too faint to study. But space-time's curvature acts like a natural telescope, magnifying the cosmos' farthest reaches and revealing details no human-built instrument could detect. These cosmic illusions are more than tricks of light, they're proof that even emptiness has structure, and that gravity doesn't just pull, it sculpts, magnifies, and sometimes shows us the same story written in multiple tenses across the sky. The most astonishing part, both effects depend on the precise alignment of objects separated by billions of light years. A slight shift in position, and the Einstein cross would vanish, the perfect ring would dissolve. That we see them at all is a reminder of the universe's vast scale, where even the unlikeliest coincidences become inevitable given enough space and time. These gravitational masterpieces aren't just rare, they're temporary. As galaxies drift, their perfect alignments will eventually break, leaving future astronomers with only dark skies where these cosmic wonders once shone. We're lucky witnesses to a vanishing act billions of years in the making. The moon's surface hides a puzzle written in eerie, swirling patterns of light and dark, mysterious streaks that spiral across the dust like celestial fingerprints. The most famous of these, Rhein Gamma, stretches over 40 miles, a cosmic brushstroke of bright material curving against the gray expanse. At first glance, they look like chalk sketches drawn by some cosmic hand, but these formations are far more than optical oddities. They're tied to something even stranger, localized magnetic fields that defy the moon's lack of a global magnetosphere. Here's the riddle: Earth's magnetic field comes from its churning molten core, a dynamo effect that shields us from solar radiation. The moon, though, it's geologically dead, its core too small and cold to generate such a planet-wide field. Yet when spacecraft map these swirls, they detect magnetic signatures strong enough to bend solar wind like invisible umbrellas shielding patches of ground. Even more baffling is how these swirls stay crisp and bright while the surrounding regolith darkens over time. Normally, the moon's surface is constantly bombarded by solar particles that slowly weather and stain it like cosmic sun bleaching in reverse. But these swirls, they're pristine, as if some force is actively protecting them. So where do these magnetic bubbles come from? One leading theory points to ancient asteroid impacts. When massive objects slam into the moon, they could vaporize iron-rich material in the crust, creating temporary plasma clouds. As these clouds cool, their minerals might retain traces of the impact's chaotic magnetism, freezing those fields into the rock like a snapshot of violence. But there's a catch: most lunar impacts don't produce swirls or magnetism this strong. Rhein Gamma, for example, doesn't even sit inside a major crater, leaving its origins utterly unclear. Then there's the wild card, comets. Some researchers suggest grazing impacts from icy comets could have draped the moon in electrically charged gases, briefly inducing magnetic fields as they skimmed the surface. It's like dragging a magnet over a sheet of metal. The fleeting contact might leave behind patches of residual magnetism, but again, why only in these elegant swirls? And how do the patterns remain so sharp after billions of years of micrometeorite erosion? The truth might lie even deeper, literally. Orbiting probes have spotted a startling correlation. Many swirls sit directly above pockets of underground magnetism, suggesting buried lava tubes or mineral deposits might be funneling residual fields upward. Imagine buried veins of iron-rich rock, relics from the moon's volcanic youth, acting like subterranean lightning rods for solar wind, deflecting particles and preserving the swirl's brightness. If that's true, these patterns aren't just surface decorations. They're windows into the moon's hidden geology, clues to a time when it was far more dynamic than it appears today. What makes these swirls so thrilling isn't just the mystery, it's what they reveal about airless worlds everywhere. If tiny, dead moons can harbor such unexpected magnetic quirks, what other surprises might lurk on Mercury, asteroids, or even distant exoplanets? Rhener Gamma and its kin are more than lunar art. They're a masterclass in how much we still have to learn about the silent, dusty world spinning in the dark. And until we land a rover right in the heart of one of these swirls, their secrets will keep drifting, untouched, just beyond our grasp. When Oumuamua streaked through our solar system in 2017, it left behind more than just a trail of cosmic dust. It sparked a mystery that still haunts astronomers today. This interstellar visitor wasn't just the first of its kind, it was a shape-shifting enigma. Radar images revealed an object unlike any asteroid or comet we'd seen before, long and narrow, stretching perhaps 800 meters end to end but only 80 meters wide, tumbling end over end like a cosmic cigar. But the real shock came when telescopes caught it doing something impossible, accelerating away from the sun faster than gravity alone could explain. Normally, comets get a speed boost from evaporating ice. Their tails act like natural thrusters, but Oumuamua showed no tail, no coma, no visible outgassing at all. So what was pushing it? Some scientists proposed hidden reservoirs of hydrogen ice, sublimating invisibly in the vacuum. Others suggested solar radiation pressure could have acted like a sail on its bizarrely flat surface if the object was just a few millimeters thick. Then came the most controversial idea. What if it wasn't natural at all? The possibility of an artificial origin, while unlikely, forced us to confront how little we truly understand about objects born around other stars. Just 2 years later, the cosmos sent us another messenger, 2I/Borisov, the first confirmed interstellar comet. Unlike Oumuamua's stark geometry, Borisov looked comfortingly familiar, with a classic coma and tail of evaporating gases. Its speed and trajectory left no doubt. This icy traveler came from another star. But here's the twist: while Oumuamua was dry and strangely reflective, Borisov was loaded with carbon monoxide, a chemical fingerprint suggesting it formed in an environment far colder than our solar system. Together, these two visitors paint a startling picture. The space between stars isn't empty. It's a highway littered with cosmic hitchhikers, each carrying clues about alien planetary systems. New data suggests these interlopers might be shockingly common. Recent estimates indicate up to 7 interstellar objects like Oumuamua could pass inside Earth's orbit every year. We've just never had telescopes sensitive enough to spot them before. Some may even be trapped in our solar system right now, hiding in plain sight among regular asteroids. The Vera Rubin Observatory, set to begin scanning the skies in 2025, could find dozens more within its first year of operation. What makes this discovery so exhilarating isn't just the objects themselves, it's what they represent. Each one is a time capsule from another corner of the galaxy, a piece of planetary rubble that drifted for millions or even billions of years before reaching us. Imagine holding a rock ejected from a world orbiting Proxima Centauri, or a fragment from a collision in the TRAPPIST-1 system. These wanderers aren't just curiosities, they are our first physical samples of distant star systems, messengers carrying stories of cosmic neighborhoods we may never visit in person. The big question now isn't whether more will come, it's what secrets they'll bring. Will the next visitor be another puzzling outlier like Oumuamua or something entirely new? One thing's certain, the age of interstellar exploration has begun, and we don't even need to leave Earth to participate. The universe is sending its mysteries to us. Buried in the afterglow of the Big Bang, a cosmic bruise lingers, an eerie void where temperatures drop sharply against the universal backdrop. Known as the cold spot, this anomaly stretches a staggering 1.8 billion light-years across, a region of the cosmic microwave background radiation where the faint whisper of the early universe is noticeably quieter. It's like pressing your hand against a warm window and feeling one icy patch, except this window is the entire observable universe, and the chill defies explanation. When scientists first mapped the cosmic microwave background, the faint echo of the universe's birth, they expected minor fluctuations, but nothing prepared them for this. The cold spot isn't just slightly cooler, its temperature plunges by about 70 microkelvin compared to surrounding regions. Statistically, that's like rolling a dice 1,000,000 times and getting 1,000,000 ones possible, but so improbable it suggests something deeper at play. So what could carve such a colossal cold patch into the fabric of space-time? One daring hypothesis proposes an unthinkable collision, our universe brushing against another in the multiverse. According to this idea, the cold spot might be a cosmic scar left by an encounter with a neighboring bubble universe, its energy draining into ours like heat seeping through a shared wall. If true, it would be the first tangible evidence of realities beyond our own, a crack in the doorway to the multiverse. But before we leap to parallel dimensions, there's a more grounded yet still bizarre explanation, a supervoid. These are vast, nearly empty regions of space where galaxies are inexplicably scarce. If the cold spot overlaps with such a void, the lack of matter could mean less gravitational pull, causing photons passing through to lose energy and cool, an effect called the integrated Sachs-Wolf effect. The problem, even the largest known supervoids are too small to explain the cold spot scale. We'd need a void so enormous it would rewrite our understanding of cosmic structure. Then there's the statistical fluke camp. Some argue the cold spot is just a rare random variation, a cosmic roll of the dice that, against all odds, landed in our observable universe. But calculations show the odds of such a fluctuation are less than 1 in 200, raising eyebrows among theorists. The truth might lie in the unknown. Could primordial physics, phases of the early universe we've yet to comprehend, have left behind such an imprint? Or is the cold spot evidence of exotic phenomena, cosmic textures, defects in space-time left over from the universe's chaotic infancy? With each new observation, the mystery deepens, challenging us to question whether we're seeing a glitch in the data or a glimpse beyond the edges of reality itself. One thing's certain, the cold spot isn't just a scientific curiosity, it's a cosmic Rorschach test. To some, it's a shadow of another universe. To others, a reminder of how much we still don't know about the vast, ancient tapestry we call home. And until we crack its code, it remains one of the universe's most tantalizing whispers, a cold, silent question written across the sky. Deep in the constellation Sagittarius, a cosmic top spins at speeds that shred the laws of physics 716 times every second, faster than a kitchen blender on its highest setting. Meet PSRJ 1748-2446 AD, a neutron star so hyperactive it stretches the very definition of what a star can endure. This pulsar, no larger than a city yet weighing more than our sun, spins with such ferocity that its equator moves at nearly 1/4 the speed of light. At that rate, the outward force should tear it apart, sending chunks of ultra-dense matter flying into space like sparks from a grinding wheel. And yet, against all odds, it holds together, defying every prediction about how neutron stars should behave. The existence of this pulsar pushes our understanding of matter to the breaking point. Neutron stars are already the universe's most extreme laboratories, atomic nuclei the size of mountains, where matter is compressed so tightly that protons and electrons fuse into neutrons. But PSRJ 1748-2446 AD takes that insanity further. Its rotation generates centrifugal forces strong enough to flatten it into an oval, distorting its shape into something more resembling a cosmic egg than a perfect sphere. The only thing preventing total disintegration is its unimaginable gravity, a force so intense that a sugar cube-sized chunk of its material would weigh as much as all of humanity combined. How does something spin this fast without exploding? One theory suggests it was born in a wild cosmic partnership, a binary system where a companion star fed it mass and angular momentum like a whirlwind romance gone astrophysical. As gas spiraled onto the neutron star, it transferred energy like a revving engine, accelerating it beyond normal limits, but even that explanation has holes. Most pulsars slow down over time as they radiate energy, yet this one seems to flirt with the theoretical speed limit for neutron stars without crossing it. Some researchers wonder if exotic states of matter, like free-floating quarks or hyperfluid cores, might be stabilizing it from within, creating a bizarre internal structure that's more slippery than solid. The implications ripple far beyond this one stellar oddity. If neutron stars can spin this fast without disintegrating, it challenges our models of how matter behaves under conditions we can't possibly replicate on Earth. It forces us to reconsider the upper limits of density, rotation, and even the nature of gravity itself. And lurking in the background is an even more electrifying question: what happens if something spins faster? Could there be neutron stars out there pushing the boundaries even further? Or does PSRJ 1748-2446 AD mark the absolute edge of what's possible? For now, this pulsar remains a cosmic daredevil, a reminder that the universe doesn't just break rules, it rewrites them. Every pulse of its radio beacon is a challenge flung across the light years, asking us to explain the impossible. And as we listen to its rapid-fire signals, one thing becomes clear. In the face of such extreme physics, our textbooks are still playing catch-up. In the distant orbit of a gas giant named Kepler 1625b, something unseen tugs at the fabric of gravity, a phantom presence that could rewrite our understanding of alien moons. This potential exomoon, dubbed Kepler 1625bi, made headlines in 2018 when astronomers spotted subtle dips in starlight that hinted at its existence. The data suggested a moon roughly the size of Neptune trailing its host planet, a cosmic dance that would make it the first exomoon ever discovered. But here's the catch, confirming it has been anything but straightforward. The evidence hinges on two key observations. First, as the planet transited its star, the light curve showed a second, smaller dip like a shadow within a shadow. Then the planet itself arrived earlier than expected in its orbit, as if an unseen mass was pulling it slightly off course. Pair these clues together, and you've got the recipe for a moon so massive it defies expectations. In our own solar system, moons are tiny compared to their planets, but this one, it's a monster, challenging the very definition of what a moon can be. Yet controversy swirls like a storm around this discovery. Some researchers argue the data could be noise artifacts from telescope calibration or stellar activity masquerading as a moon. Others point out that a moon this large should have formed differently than anything we've seen, possibly as a captured planet or a fragment from a cataclysmic collision. The debate rages on, with follow-up observations so far inconclusive. If Kepler 1625b is real, it's not just a moon, it's a cosmic outlier, a reminder that the universe loves to break the rules. Now shift your gaze to a cosmic explosion that shouldn't exist where it appeared. In 2013, a supernova flared to life in a stretch of space devoid of galaxies, a stellar catastrophe with no obvious source. Dubbed SN 2013 FC, this rogue supernova defied logic. Supernovae are supposed to mark the violent deaths of massive stars, and stars don't just float alone in the void. So how did this one detonate in the middle of nowhere? The leading theory is as dramatic as the event itself. A runaway white dwarf ejected from its home galaxy at blistering speeds finally met its end. Imagine a stellar zombie, already dead but still glowing, hurled into the darkness by a close encounter with a supermassive black hole. Drifting for millions of years, it eventually collided with another wandering star or accumulated enough material to reignite, triggering a thermonuclear explosion far from any galactic neighborhood. But there's a twist. Some astronomers propose an even wilder origin. A primordial black hole, one of the universe's first, might have shredded and ignited a passing star, mimicking a supernova without the need for a white dwarf. Or perhaps we're seeing light bent by gravitational lensing, distorting the supernova's true location. Whatever the explanation, SN 2013 FC is a ghostly reminder that the cosmos is full of drifters, lonely objects adrift in the dark, waiting to reveal themselves in bursts of violence we're only beginning to understand. Together, these two enigmas, the phantom exomoon and the rogue supernova, showcase the universe's flair for the unexpected. Whether it's a moon too big to exist or an explosion with no home, they force us to question the boundaries of what we think we know. And in that uncertainty lies the thrill of discovery. The cosmos will always have another surprise, another mystery waiting just beyond the edge of our understanding. At first glance, the sun seems straightforward, a blazing ball of fire with temperatures climbing the closer you get to its core. But look closer, and you'll find a cosmic contradiction that defies intuition. The sun's visible surface, the photosphere, simmers at a toasty 5,500 degrees Celsius. Yet just above it, in the wispy outer atmosphere called the corona, the temperature skyrockets to a staggering 1 to 2 million degrees. It's like stepping away from a campfire and suddenly feeling your face sear as if you'd stuck it in the flames. This is the coronal heating problem, and for decades it's left scientists baffled. The laws of thermodynamics say heat shouldn't behave this way. Normally, temperatures drop as you move away from a heat source. Think of how a spoon cools when pulled from hot soup. But the sun flips this logic on its head. One leading theory points to nanoflares, tiny explosions peppering the corona like popcorn kernels popping in a cosmic microwave. Unlike their larger cousins, solar flares, which unleash energy equivalent to millions of hydrogen bombs, nanoflares are minuscule, just 1/1000th the size. But there's a twist. They might be everywhere, erupting non-stop in such vast numbers that their combined heat could solve the mystery. Then there's the role of the sun's tangled magnetic fields. Picture spaghetti thrown into a blender. That's the corona's magnetic landscape, with lines constantly crossing, snapping, and reconnecting. This process, called magnetic reconnection, unleashes bursts of energy as fields rearrange themselves. It's like stretching a rubber band until it snaps, but on a scale where the snap heats plasma to millions of degrees. Satellite missions like NASA's Parker solar probe are diving closer to the sun than ever before, revealing chaotic swirls of plasma caught in these magnetic dances. But the plot thickens. Some researchers argue the corona's heat might come from Alfvén waves, ripples in the magnetic field that carry energy outward like ocean waves crashing onto a shore. These waves could transfer heat from the sun's churning interior to the corona, bypassing the cooler surface entirely. others speculate the answer lies in a combination of mechanisms, nanoflares, reconnection, and waves working in concert, a symphony of physics we've yet to fully decipher. The stakes are higher than just solving a stellar puzzle. Understanding coronal heating could unlock secrets about solar wind, space weather, and even the habitability of planets around other stars. If we crack this code, we might predict solar storms that threaten satellites or unravel why some stars flicker unpredictably. For now, the corona remains a sizzling enigma, a reminder that even the most familiar objects in the sky can hide the most astonishing secrets. Between the glittering islands of galaxies lies an invisible architecture, threads of gas so faint they were only discovered by the shadows they cast. These filaments, stretching millions of light years like cosmic spider silk, form the backbone of the universe. Scientists call it the cosmic web, and it's the hidden scaffolding that dictates where galaxies form, cluster, and drift apart. For decades, this structure existed only in theory until astronomers turned to nature's flashlights, quasars. These ultra-bright galactic cores, powered by voracious black holes, beam light across the universe. When that light passes through a filament, certain wavelengths get absorbed, revealing the fingerprint of hydrogen gas, the universe's most basic building material. What makes these filaments so extraordinary isn't just their scale, but their precision. They trace paths where dark matter's gravity carved rivers through the early universe, guiding ordinary matter into their currents. Picture a network of highways where gas flows at speeds exceeding 1 million kilometers per hour, funneling fuel into galaxy clusters like water rushing into a drain. Without these threads, galaxies would starve, cut off from the raw material needed to birth new stars. Yet detecting them is like trying to spot a whisper in a hurricane. The gas is so diffuse, just a few atoms per cubic meter, that it's only visible when backlit by quasars hundreds of times brighter than entire galaxies. Even more mind-bending is how these filaments defy time. Some are relics from the universe's infancy, stretching back to when the first structures coalesced after the Big Bang. Others are still evolving, vibrating with shock waves from galactic collisions or the explosive deaths of stars. Simulations suggest these threads should crisscross in a predictable grid, but real observations reveal tangles and knots like a web shaken by invisible winds. Some filaments even glow faintly with UV light, energized by the radiation of countless galaxies along their length. The cosmic web isn't just a curiosity, it's a missing link in understanding how the universe organizes itself. By mapping its tendrils, scientists can test theories of dark matter's role in cosmic evolution or predict where the next generation of galaxies will emerge. And as telescopes grow more sensitive, we're beginning to see hints of an even grander structure, filaments connecting superclusters, weaving the universe into a single, intricate tapestry. What began as theoretical scribbles on astrophysicists' chalkboards is now revealing itself as the universe's true skeleton, a hidden framework written in gas, gravity, and light. We've scoured the cosmos for signs of intelligent life, listening for radio whispers, scanning for megastructures, even hunting for alien pollutants in distant atmospheres. Yet the universe remains silent, a mystery so profound it has a name, the Fermi paradox. If the galaxy is teeming with habitable worlds, where is everybody? New research suggests the answer might be more unsettling than we imagined. The latest calculations hint that advanced civilizations could be vanishingly rare, not because they don't exist, but because the window for their survival might be impossibly narrow. Take the Drake equation, the famous formula estimating the number of communicative civilizations in our galaxy. For decades, we've plugged in hopeful numbers, billions of stars, Earth-like planets aplenty. But recent exoplanet data forces a sobering rethink. Sure, we've found thousands of worlds, but how many are truly hospitable? Many orbit turbulent red dwarfs bathed in deadly flares. Others are tidally locked, with one side scorched and the other frozen. Even Earth's delicate balance plate tectonics, a stable moon, a magnetic shield now seems less like a cosmic baseline and more like winning the lottery. Then there's the great filter, the idea that some catastrophic hurdle prevents life from reaching the stars. Is it behind us, meaning we've already beaten the odds? Or worse, ahead of us, lurking in our future, new simulations suggest a chilling possibility. Technological civilizations might self-destruct faster than they can spread. Climate collapse, AI gone rogue, nuclear war, any could snuff out a species just as it reaches for the cosmos. The silence we hear might not be absence. It might be aftermath, yet there's a twist. Some astronomers argue we're looking for the wrong things. Advanced civilizations might communicate via neutrino beams or quantum entanglement, technologies invisible to our primitive scanners. Others could have transcended biology entirely, existing as pure information in Dyson swarms, or perhaps they've chosen silence, hiding from something we can't yet comprehend. The paradox endures not because the answers aren't there, but because we're still learning how to ask the questions. Every discovery, every Earth-like world, every unexpected cosmic hurdle sharpens the puzzle. The universe isn't just showing us where life could be, it's showing us how fragile, how fleeting, how extraordinary our own existence might truly be. Back in 2019, Stephen Hawking's final paper landed like a bombshell, reigniting a debate that has haunted physicists for decades, the black hole information paradox. At its heart lies a simple question with universe-shattering implications. When something falls into a black hole, is its information truly lost forever? This isn't just about cosmic bookkeeping. It challenges the foundational principle of quantum mechanics that information can never be destroyed. Yet black holes, with their infamous event horizons, seem to erase it without a trace. Enter Hawking radiation, the faint glow of particles escaping a black hole's grip, carrying energy but seemingly no data about what was swallowed. Hawking's original theory suggested this radiation was random, a thermal fizz of particles with no connection to the original infalling matter. Imagine burning a library full of books. The heat and smoke tell you nothing about Shakespeare or Einstein, but here's where it gets weird. Quantum mechanics insists that information, like the plot of those burned books, must somehow persist. If it doesn't, our entire understanding of reality unravels. Recent breakthroughs hint at a solution hiding in the black hole's soft hair, subtle imprints left on the event horizon. Picture dipping your finger into water. The ripples carry a memory of your touch. Similarly, as particles cross the horizon, they might leave faint quantum fingerprints in gravitational or electromagnetic fields, preserving information in ways we're only beginning to decode. Some theorists even propose that Hawking radiation isn't random after all, that entangled particles inside and outside the black hole encode a scrambled version of the original data, like a cosmic jigsaw puzzle waiting to be reassembled. But the debate is far from settled. Critics argue that if information escapes, it violates Einstein's equivalence principle, turning the event horizon into a fiery membrane that fries incoming matter, a scenario dubbed the firewall paradox. Others suggest black holes might not evaporate completely, leaving behind microscopic remnants packed with data, akin to a USB drive surviving a nuclear blast. Meanwhile, the burping black hole we discussed earlier adds another layer. If black holes can emit periodic X-ray flares, might those bursts also carry encoded information? Could the universe have built-in backup systems we haven't discovered yet? The stakes couldn't be higher. If information isn't lost, it means black holes are the ultimate cryptographers, hiding secrets in plain sight. If it is, we might need to rewrite the laws of physics. One thing's certain, the paradox forces us to confront the limits of our knowledge. Whether through Hawking radiation, soft hair, or some yet undreamed mechanism, the answer will redefine not just black holes, but the very nature of reality itself. And until we crack this cosmic cipher, the universe's most destructive objects remain its most tantalizing enigmas. The S1 stream, that invisible hurricane of dark matter tearing through our galaxy, isn't just a scientific curiosity. It's a spotlight on one of the most humbling truths in modern physics. 85% of the universe's mass is missing. Not misplaced, not hidden, but fundamentally undetectable by any instrument we've built. Dark matter doesn't absorb, emit, or reflect light. It doesn't collide with atoms. It's a ghost felt only by the way its gravity sculpts galaxies and bends the fabric of space-time. And after decades of hunting, we still don't know what it's made of. Take WIMP, or weakly interacting massive particles, the longtime frontrunners in the dark matter debate. These hypothetical heavyweights would be like cosmic neutrinos, uncharged, nearly invisible, but massive enough to explain the gravitational glue holding galaxies together. Underground labs like Italy's Gran Sasso have spent years searching for WIMP, using vats of liquid xenon as bait. The idea: if a WIMP bumps into a xenon nucleus, the faintest flash of light or ripple of charge might betray its presence. Yet after countless experiments, the detectors remain silent. Either WIMP are rarer than predicted, or they're not there at all. Then there are actions, the dark matter underdogs. Unlike bulky WIMP, these hypothetical particles would be feather-light, 1 trillion times less massive than an electron. They were dreamed up to solve a totally unrelated puzzle in quantum physics, but their behavior, cold, abundant, and barely interacting, fits dark matter's profile eerily well. Experiments like the Action Dark Matter experiment use powerful magnetic fields to coax actions into revealing themselves, converting into detectable microwave photons. It's like tuning a cosmic radio, searching for a whisper in a storm of static. While no action has been caught yet, their delicate nature means they could have evaded detection all this time. But the plot thickens. Some theorists argue we've been looking in the wrong direction entirely. What if dark matter isn't a single particle but a shadow universe of undiscovered forces and interactions? Modified Newtonian dynamics suggests gravity itself behaves differently at cosmic scales, eliminating the need for dark matter altogether. Yet man can't explain the bullet cluster where colliding galaxies left visible matter and gravitational effects visibly divorced, a smoking gun for dark matter's existence. The S1 stream adds another layer of intrigue. Its density and speed suggest dark matter might cluster more tightly than models predict, or that its particles interact with each other in ways we can't yet see. Simulations show streams like S1 should fray over time, their stars scattering like sand in a windstorm. Yet this one remains coherent, hinting at unseen forces at play. Here's the kicker: dark matter's elusiveness might be the universe's way of telling us our physics is incomplete. From supersymmetry to extra dimensions, every dead end in the hunt pushes us toward wilder, more revolutionary ideas. The S1 hurricane isn't just a mystery, it's an invitation to rewrite the rules. And until we do, 85% of reality will remain a tantalizing blank space waiting to be filled. The cold spot isn't just a glitch in the cosmic background. It could be a bruise left by another universe bumping into ours. This bold idea springs from the multiverse hypothesis, a theory suggesting our cosmos is just one bubble in an endless froth of realities, each with its own physics, its own rules. Picture soap suds in a sink, each bubble a self-contained universe, occasionally brushing against others. If one of those collisions happened early in our universe's life, the energy drain from that contact might have left behind a chill in the cosmic microwave background, a cold patch like a fingerprint on glass. But how could another universe even leave a mark? Quantum fluctuations during the Big Bang could have created pockets of space-time that inflated at different rates, birthing separate bubble universes. Some of these bubbles might have briefly touched, their boundaries interacting like cells in a hive. The cold spot's strange temperature drop aligns eerily with simulations of such an encounter. It's as if we're staring at a cosmic bruise where the energy of our universe leaked into another. Not everyone's convinced. Critics argue the cold spot could just be a statistical fluke, a 1 in 200 anomaly in an otherwise uniform sky. But here's the twist: the cold spot isn't just cold, it's surrounded by a faintly warmer ring. Exactly what you'd expect if a bubble universe had nudged ours, creating ripples in space-time. It's like finding a splash pattern around a raindrop, evidence of an impact. Then there's the quantum angle. Some theorists propose the cold spot isn't a collision scar but a quantum fluctuation frozen in time. In the instant after the Big Bang, random variations in energy density could have left behind over dense or under dense regions. Most smoothed out as the universe expanded, but a particularly large fluctuation might have frozen into place, creating a void like the cold spot. Imagine blowing up a balloon with a thin patch. As it inflates, that weak spot stretches into a noticeable dip. The stakes: if the cold spot is proof of a multiverse, it rewrites our place in reality. We're no longer just one universe but neighbors in an infinite cosmic neighborhood, each bubble operating by its own laws. Some might harbor alternate versions of physics where stars never formed. Others could be so alien they're beyond comprehension. And if quantum fluctuations can leave imprints this vast, it hints at a universe far more chaotic and interconnected than we ever imagined. For now, the cold spot remains a riddle, one that could either upend cosmology or fade into the noise of cosmic anomalies. But whether it's a multiverse's fingerprint or a quantum hiccup, it's a reminder that the universe loves a good mystery, and the deeper we look, the stranger the answers become. From vanishing stars to diamond planets, rogue black holes to phantom galaxies, these 25 cosmic events aren't just oddities, they're windows into the universe's infinite creativity. Each one defies expectations, twists the rules, and reminds us that reality is far stranger than fiction. Fast radio bursts pulsing like coded messages, dark matter hurricanes ripping through our galaxy, entire stars disappearing without a trace. These aren't glitches in the system. They're proof that the cosmos operates on a scale of wonder we're only beginning to grasp. What makes these mysteries so thrilling isn't just their weirdness, it's how they push science to its limits. Every time we think we've figured things out, the universe throws a curveball. A black hole burps on schedule, a galaxy spins without dark matter, a cold spot in the sky hints at parallel realities. These aren't problems to solve, they're invitations to explore, to question, to rethink everything we thought we knew. The greatest discoveries often start with a single baffling observation, a crack in the facade of our understanding where something extraordinary slips through. And that's the beauty of it. Science isn't a static list of facts, it's a living, breathing pursuit fueled by curiosity. Each of these 25 events represents a frontier, a challenge hurled at us by the cosmos. Figure this out if you can. Whether it's the whispers of a multiverse or the enigma of dark matter's invisible grip, these puzzles aren't just about answers. They're about the journey, the telescopes built, the theories tested, the minds stretched to their limits. So tell us which of these cosmic riddles hooks you. Is it the star that shouldn't exist, packed with impossible elements, the rogue planet wandering the void alone? Or the eerie silence that makes us wonder if we're truly alone in the universe? Drop your thoughts in the comments, and remember, the next great discovery might start with a single question, a single what if. The universe is out there, waiting to surprise us. All we have to do is keep looking, stay curious.